The relief valve on the 2-inch 575 was probably the most modified assembly component ever built. This is what the 2-inch 1.25 through 2-inch 575 relief valve body looks like, mounted on the side. There's 2 external relief valve sensing lines. First key difference you want to look at is this. Do you have the old style, which like this has a bolt head, as you can see there, or is it the new style, like this one, that has a nut with a stud protruding through the back? So it'll either be like this, where it's a bolt, or this, where it's a nut and a stud. We want to see this one. This is the new style. Newer style, I should say. There's actually 1, 2, 3, 4, 5, 6, 7, 8 stems we're going to go through right now. And of these 8 stems, let's see, 4 of them are going to be the old style. It looks like 4 are going to be the new style. But anyway, this is the older style, new style. This is the older style with the head on it like that. So let's go ahead and take the old style apart first. See what it looked like. Whoops, grab the wrong one. Old style first. Remove our 2 relief valve sensing lines. You can see the air bleed screw on the top. We're going to remove our 6 RV cover bolts. There will be spring tension underneath. Go ahead and remove our relief valve cover, our relief valve spring. That same spring retainer like we saw on the 3/4 2-inch that balances on the tip of the stem, again to divert the spring load through the center of the stem. Once that comes off, unscrew our bolt on the top, which has a special O-ring washer underneath the bolt head. Upper diaphragm plate, diaphragm, lower diaphragm plate. Relief valve stem sticks up through the top. You can see the overspray of the black, just like we saw on the 3/4 and 1-inch. Now I'm going to turn the body upside down and push the stem out from the top. Just like with the 3/4 and 1, I've got to pull the stem out in order to remove the stem from the body. But what holds it into the body is the relief valve seat. There are 3 Allen head screws, again 9/64 Allen head screw. Get in, remove those 3 screws. The stem will come out in one piece. There you can see a close-up of that black plasticized covering inside there. Here's the stem. To remove the seat off of the stem, we have 1 bolt holds the relief valve disc, relief valve seat, 2 stem O-rings right here. And that's the parts of the 575 relief valve. Now, as I alluded to, this is the most modified assembly in history. 8 different relief valve versions were produced. Good news is the rubber repair kit fits most of the versions. When I say it that way, yes, you can rebuild all versions you have with the relief valve kit. But I want to show you some of the problems that took place on this over the years and why we had so many changes. Okay, first and foremost was this relief valve seat. The profile of the seat was extremely sharp. It was almost a knife-edge seat. So unfortunately what happened was a lot of times that when this relief valve disc was embedded, actually it would look more like this in life coming up, it would embed into that seat and it would not come off of the seat. In other words, the disc got embedded into the seat and they had issues with the relief valve not opening. It used to open regularly under 2 pounds. It did not open usually above 2 pounds. It would be exercised a few times and it would work fine. So the engineers were trying to figure out what's making this thing stick, if you will, so that they could replace it and fix it accordingly. This was the stem that they started with, and it looked like this. Relief valve disc was on the bottom, the seat was here, diaphragm was on top. In other words, the way this works in the real working assembly was that the stem went down to open, it went up to close. So what was happening in a closed position like this, unfortunately, when you go to test it, the relief valve wouldn't open because the disc wouldn't come off of the seat. So again, back to the earliest generation was this one. And what was concerned was that this diaphragm was pushing down, even with that sharp-shaped spring knob on the top pushing down the stem. They were afraid that it was wobbling sideways and that it wasn't stable, and that's why it wouldn't come off of there. So the second generation, they went to a full 4-guided stem on the bottom, thinking that the problem was the guide on the bottom wasn't holding it well. This would keep it so that it moves straight up and down, all the force coming off. That didn't help. Next one they tried was taking that same basic design. They just tried hard plating it, thinking that the chrome plating might help it so the 2 bronzes don't stick together. Still had issues with that, so the next generation they tried, they went to a plastic material on the upper portion of the stem. The concern was that the bronze was bonding into the body here with the old version like this, and so they thought by making it a plastic material, the two bronzes wouldn't interact, corrode together, and be stuck. So by putting the plastic material in here, they thought there wouldn't be as much issue. They also went from an O-ring design. In other words, the original version, this was an O-ring. If you look close up here, this is actually a quad ring or a square ring. Yes, there is a quad ring. We talked about those earlier. And this is a quad ring example. Still had issues with the relief valve opening point. So the next idea was to try this. And they thought that maybe the problem wasn't the lower guide, as they had been thinking all this time. They thought maybe it was the upper guide. So what they did to the upper guide is they went from a brass piece like this to a stainless piece, thinking, okay, we'll go to a different metal, see if by going to a different metal on the top of the stem where it protrudes through here, through that little plastic coating, that'll make it so it didn't stick. Still had issues. Next idea was to try this, where they went to an all-plastic stem, but instead of it having a bolt head on the bottom, here's where our stud came up. Remember I showed you the two versions, the old version where it went in with a screw and the new version where there was a stud sticking through where we had a nut attach it. So this was the first interjection of the complete plastic stem. It was two pieces with a stainless steel stem in the middle. The upper portion of the stem was held with an E-ring. You can see there on the top. Trouble was, remember that this goes in an up fashion to close. What happened after it closed several times is the E-ring would be pushed off of the stem and break it apart. So the next generation they tried, they had to make it more solid stop up there, and what they did is they took a small little piece of stainless and put a little clip in there and actually screwed that little stop ring on the top of the stem. Same two-piece construction. That was kind of expensive to make, so the final design that they made is this one, where the stem was one-piece stainless, where they actually machined that stop in the top, two-piece plastic, quad ring, stainless on the top, plastic here. After they got that far, they discontinued the model from production. So that's the 575 inch and a quarter through 2 inch relief valve stems that you may see on this particular design. You could have one of any of those stems. The rubber repair kit will repair most of the versions. The only trouble you're going to have sometimes is on the upper portion with some of the O-rings, and I'll show you some of the other parts that change when we put it back together. So let's go ahead and put the stem together, the one we took apart. First we're going to have is, of course, our relief valve seat, seat O-ring. Place our two O-rings or the quad ring, depending which version we had on the relief valve stem. Relief valve seat, relief valve disc, and our disc retainer. This being the old style, we have a bolt on the bottom, where the new style would have had a stud protruding through with a nut. Once I have it in place, make sure that sits evenly on my seat. Grab my body. Remember, I have to insert my stem in from the bottom. Once I get it in, push the stem in place. My 3 9/64 Allen head screws, attach the relief valve seat to the body, and yes, I only have one because it's a demo. Turn it upside down, making sure the stem is pushing all the way up. I want my lower diaphragm plate, and you can tell the lower one because it has a recess to hold the diaphragm. Here's the recess, and there's the flat side. Then the flat side, the recess goes into here. Upper diaphragm plate. Washer. Washer has the O-ring washer on the top, in the old style like this. Tighten it in place. As I mentioned earlier, there were some different distinct styles. This one had what the top of the new style stem would look like, one of the plastic ones. Instead of it being two brass pieces, like you saw here in the diaphragm retainers, you may have seen the stainless steel disc diaphragm retainer like that. And that was used quite a bit, and at the end, and when they did, they went to two stem O-rings on the stem. So instead of the washer with the O-ring under the bolt, you're going to have the diaphragm plate with the O-ring under this, and this with those two extra O-rings you'll find in the rubber repair kit are for. So whichever version you have, the top will be slightly different, and just as the bottom will be slightly different. Now we want to go ahead and mount our spring retainer in the very center. Make sure it spins easily so we know we've got it centered on the stem. Mount your relief valve cover so that it connects to the relief valve sensing line, which happens to be right in line with the relief valve discharge. Go ahead, get all your relief valve cover bolts on. Very, very, very important when we put this back together was to make sure all the air was bled out of not only the checks but the relief valve. Relief valve had an air bleed up here, but it also had a relief valve bleed down here. Remember, we showed you on that 3/4 on the cutaway that as the stem moves up and back, there is air between this diaphragm and that large piston O-ring, like that. So here's where that large piston O-ring, here's where the diaphragm will be sitting right along here. And as it moves back and forth, that little bleed that you see right there is to let air breathe as the diaphragm moves up and down. But that screw right there is to take air out from the bottom half of the diaphragm. Because if you have air trapped on the bottom of the diaphragm, air compresses, water doesn't. And remember, we're pushing the relief valve disc up to close. It can cause it to vibrate and make the relief valve discharge or spit. So showing you where it sits in like that, there's this air bleed, the air screw bleed right here, and then there's the breathing hole right there. Both very important for the working of this particular relief valve stem. And then mounting it onto the body, it mounts with an O-ring, so we don't have the gasket like we did on the 3/4 through 1 inch to worry about. 2 bolts puts it on the edge of the check body. 2 relief valve sensing lines, a high and a low. And that's what our 2-inch 575 is going to look like. Now let's talk about the larger sizes, larger meaning 2.5 through 6 inch. Here's a copy of a 3-inch valve I've got in front of me. This happens to be the 575 version, which is the RP version. The relief valve mounts underneath like this. There are 2 studs on the bottom side, and that relief valve mounts right there. I got it apart just so we can go ahead and take it apart. Let's talk about the check valves first. First thing you'll notice on the 575 is that there are 2 styles of covers. The second check has a flat cover like you see here, and the first check has a raised up here, has a raised cover. So you're going to see the flat style and the raised style. First check on the RP will be raised. On the double check, the top will be flat, just like the second check. So anyway, obviously we'll have a relief valve if it's an RP. But the reason I want to show you that is because that's got a lot to do with what's underneath that cover. So let's go ahead. 2 external relief valve sensing lines, we remove those. We remove our relief valve body for the repair. I'm going to do our checks first. This being a 575, it's going to have the larger loaded spring underneath. Once I take the cover off, what I see is this. My spring stem assembly comes out in one piece, just like this. Underneath it will be the check seat, which comes out in one piece like that. And then inside the body, which is just epoxy coated, plain the epoxy coating there. So what it looks like inside the body is this piece, which is my check seat, is sealed by an O-ring on the bottom and an O-ring on the top. It goes into the body like this. The relief valve stem assembly goes in just like that. So it's a piston style check, just like we saw with the smaller ones. And the seat itself actually comes out, the sleeve comes out of the body with the seat, just like that. So basically you're going to have 2 types of check assemblies. You're going to have a contained spring like this one, or in the second check what you're going to find is an uncontained spring like this one, where the check spring sits in the center of it like this. So raised top, contained spring, flat will be the uncontained second check, just like that. Check seats are replaceable. As you can see, they come out in an entire piece like that. Checks are sealed in the body with an O-ring. Let's put this on the side for a second and talk about the body while we're at it. Another important thing on the body with the 575 version has to do with where the high pressure relief valve sensing line is attached. Underneath the body, on the inlet of the number 1 shutoff, here's where my relief valve would be attached like this. The high pressure sensing line comes out this hole right here. Now what you would normally see would be this tubing like that to connect to it. But if you could pull that fitting out, what you're going to see is this. This is what's called a pitot tube. Now, if we take this check assembly back in line like this and take a look, what you would be seeing from inside is this. That stainless steel tubing is called a pitot tube. And the function of that pitot tube is to put that sensing line in the very center of the water, or not the very center, but in the center area of the water line. The reason is, this particular body design, when you look at it from the side, is relatively short and compact. And the check assemblies, the way they operate at that Y pattern, when the first check pulls out of the water passageway and the second check pulls out of the water passageway, we have a fairly unrestricted water flow through here. It creates a high turbulence, a high velocity issue that causes a problem where if it goes so fast past there, what can happen is it can actually siphon the water off of this point, which takes the high pressure sensing line off our high side of our relief valve opening point. By having the pitot tube with that sensing line in the very center, near the center, not in the very center, but near the center, what it does is it makes sure that as the water goes past at high velocity, it does not siphon the water off the top of our relief valve diaphragm. So, very important part of that relief valve is that little tube sticking up there. Unfortunately, sometimes if that tubing breaks off on the bottom or the fitting breaks off, people have just gone to their compression fittings and gotten different sizes of fittings to put in there. It has to have that pitot tube. Make sure that that works properly. Okay, let's go back to the check assemblies. Put this body down for a second. If it's the contained spring, which on the first check of the 2.5, 3, and 4, and the second check of the 4 and 6, 2.5, 3, 4, and 6 first check are contained, 4 and 6 inch of the second check are contained. All you have to do is remove one bolt on the bottom, change your check disc out, and put the new one in. On the second check, which has the uncontained spring, same story. One bolt off, change the disc, put it back in. They're both piston style checks, so same things we talked about with the other sizes, the 3/4 through 2. Now, reassembly, we have to kind of follow a few little rules. First thing we have to do is put the seat in. Notice there's a large hole in the seat. It goes one way. Guess which way it goes so that the water can travel through there. In other words, as you see inside the body, if I slide this in there like this, water comes up from the bottom and slides out there. If I turned it around that way, guess what would happen? Water wouldn't go out. Well, good news is you really can't do it because of this pin right here. The pin lines up with this hole right here, which allows me to get the 3-inch seat just like that. Now on the larger 4 and 6 inch, there are actually 2 screws that hold the seat into the body. But on the 3-inch, they did not put the screws, but it has the little recess on it. But that pin has to sit on the bottom, just like that. If you tried to put it in backwards, you couldn't because the pin would be in the way. So anyway, it goes just like that. Now we can go ahead and take our check assembly, which is also something else we have to notice. There's a knob on the top right here. So we have to make sure that knob goes in with the pin. I'll show you why in just a second. So there, knob in line with the pin. Because if you look at the cover on the inside, you'll notice there is a wide recess area and there's a thin recess area. Obviously that notch is only going to fit in the wide area right there. There have been a couple modifications of this check assembly over the years, and I want to show you the different ones. The first one they utilized on this check assembly, and obviously the spring isn't on this, they used a square, relatively sharp brass stem. That spring sat like this, and the retainer cup pushed down on the spring, and that's what it would look like without the spring. The spring retainer also had that square, sharp cut on the stem. And unfortunately what would happen is it tended to bind a lot of times. You can see as I push this up and down, it makes a lot of noise. And there's a very tight, close tolerances between those two. And unfortunately sometimes it would just cock to one side or the other, stick, and the check valve would hang open. So they refined it and changed it to a rounded, cornered stainless steel tube like this. The tube replaced the sharp brass one, and the spring retainer also had a rounded cup, so that it would slide easier as it moved up and down as the check assembly moved. It had more tolerances where it could move sideways and not hang up like it did on the original version like this. So either version you may find out there. Now we can reassemble this, making sure I've got the wide passageway here on my cover over the little recess. Line up my 4 holes, bolt holes. Second check on the 2.5 and 3 inch is going to be uncontained. So as I go to put it back in, I'm going to have to compress that spring and shove into the cover into the second check. That's the check assemblies on the 575 and the 550, 2.5 through 6 inch. Here's the relief valve on the 2.5 through 6 inch 575. We had our high pressure sensing line which attached to the cover. We had our low pressure sensing line over here on the back side. Notice there's an air bleed right there on the back of where the inlet and where the high pressure cover comes in. Obviously important to bleed air out of this, just like we talked about in the smaller sizes. Remove our relief valve cover bolts. Again, we have to remove the entire relief valve body from the check body for repair. Relief valve cover bolts, the relief valve cover comes off. First thing you're going to notice is a nut with a bronze stem in the center that has a screwdriver slot. So what that means we have to do is get in here with our screwdriver, with a wrench, and loosen it just like this. It's much more important when we go to tightening it that we use that particular combination. Once I have it loose, one nut comes off, the belt, that rolling diaphragm washer, rolling diaphragm, diaphragm support. There was spring tension underneath that little nut when I finally removed it, as you saw. Relief valve spring comes out next. What happens next I see is my relief valve stem. Just like with the 3/4 through 2, we've got to turn it upside down to get the seat out. So now we have 3 screws we have to remove here. And again, I've lost most of them, so I have just one. Once that comes off, the stem guide comes out in one piece like this. What's exposed down there now is a lower bellafram. So there are 2 bellaframs on this particular design, the 2.5 through 6, unlike the smaller ones which only had the single bellafram. So now that I have that, turn it upside down. There are 3 bolts that hold my relief valve seat flange on there. Go ahead and remove those. Relief valve seat comes out in one piece, just like this. My relief valve seat inside. To remove it, I have to disassemble my rolling diaphragm. 3 screws again in here. Rolling diaphragm comes out. Stem will come out from the bottom, just like that. 1 screw holds the relief valve disc into the relief valve disc holder. So those are the parts of the relief valve stem. Upper rolling diaphragm, which has the main movement of the relief valve. There's a lower diaphragm, which sits between this stationary spacer, acts as a guide, showing you what it looks like outside of the body. It's just like this. Sits on top of the relief valve seat here. This rolling diaphragm guides it. The upper diaphragm on top is what causes the movement of the relief valve stem. Obviously, relief valve spring in there. So let's go ahead and put it back together now. Put our new bolt back, our new relief valve disc back into our stem. Relief valve seat now goes in from the bottom, and I want to attach it in there because I'm going to use that as a guide to put the rolling diaphragm back in. You notice I took it out first to get it out. That's so I didn't damage the seat. But now I have to use that seat as a little holding place to hold that diaphragm in place. So what I've got now is my stem sticking up like this. I'm going to take my rolling diaphragm, placing it over those 3 holes with the washer on top. Now I'm going to place the rolling diaphragm over the washer, over the stem with the rolling diaphragm washer. I'm going to have my 3 screws. I'll show you in just a second. So I'm going to attach the 3 screws here. And if I had a camera on top of me, you could see it. Okay, so the 3 screws now go in to hold the rolling diaphragm in place. Now what I want to do is go ahead and move my relief valve stem up, folding the rolling diaphragm down on the outer lip. What that does, that lip side has to go into the recess. Pushing it into the recess, once I have the diaphragm in its shape, now I can push down, and that'll make sure it's folded just like that. Very important that rolling diaphragm be folded all the way around. So you pull it out, put the outer lip in, push it down, the center will collapse in the center, and that'll line up the relief valve stem. Now I need my relief valve guide, which goes over here. Again, 3 screws go in here, hold the 3 screws in the stem. Relief valve spring, my relief valve stem O-ring, my relief valve rolling diaphragm retainer. Now, this is the part that's caused probably the most trouble of this over the years, is getting this nut tight. You can see that we've got a relatively large, meaning about 4-inch diameter rolling diaphragm, and a very, very small 3/8 nut. There's no O-ring assistance on sealing this stem to the top of this diaphragm. So I have to use my screwdriver. That's why there's a screwdriver slot in the center of that stem. and my wrench on the nut and make sure this is tight. How tight? As tight as you can. That has to be very, very tight. Slight loosening of that will cause water to drip through there, and the relief valve is going to discharge like it's leaking. So that's why that screwdriver slot's there, so I can turn that. Now remember, I don't want to turn this. Remember that rolling diaphragm inside? If I start turning this, what happens to that diaphragm? It twists, and it will not work. So make very sure that you don't twist that, but just as importantly, make sure it's extremely tight on the top here. Relief valve cover goes on next, making sure we've got the air bleed to the top portion so that our sensing lines hook back up. Again, there's the discharge, there's the air bleed. Relief valve cover bolts. The relief valve assembly, when I've got it back together, attaches to the check body, sealed with an O-ring seal that you see right here. And that's my 575 2.5 through 6 inch relief valve assembly.